Welcome students to second quarter, and we are now on our week 1. For this week lessons we will be dealing with milk number 6. Explain how quantum mechanical model of an atom describes the energies and position of electrons. Here are the lesson objectives. First, at the end of the lesson, you need to illustrate the development of atomic models and predict the probable location of electrons in an atom. Include in the discussion the electron cloud and Heisenberg's uncertainty principle. Second one, describe electron configuration and write the correct electron configuration of a given element. And last, supply the following data from the electron configuration, such as the period number, group number, number of paired and unpaired electrons, number of valence electrons, and number of core electrons. Here are the lesson coverage for today. We will be discussing the model of atoms and the electron configuration. Atom was first described by John Dalton as it involves the following postulates. First, element consists of invisible small particles called atoms. All atoms of the same elements are identical. Different elements have different types of atom. And third, atom can neither be created nor destroyed. He described atom as a ball, just like the billiard ball. Second one is J.J. Thomson. On J.J. Thomson's atomic model, he described atom that is composed of electrons surrounded by a soup of positive charge to balance the electron negative charges, like negatively charged plums surrounded by positively charged pudding. Third is Ernest Rutherford. On the theory or on the model of Rutherford, he described atom as a tiny, dense, positively charged core called nucleus, in which nearly all the mass is concentrated, around which the light negative constituents, called electrons, circulate at some distance, much like planets revolving around the sun. Next atomic model was proposed by Niels Bohr. He described an atom consisting of a small, positively charged nucleus orbited by negatively charged electrons. Each orbit or shell of the atom is called the principal energy level, which consists different levels of energy, and it is being represented by letter N. Bohr model was being questioned because of the different situations or conditions happens on the electrons around the nucleus, because some scientists observed that the electrons changes its position or travels from one orbit to another orbit by emitting photon or an energy. Using the model of Bohr, different scientists now describe atom more specifically or more clearer, and one of the theory that follows or modified the theory of or model of Niels Bohr is the quantum mechanical model, wherein it describes that there is only a probable or possible position for electrons within an atom using atomic orbitals. Quantum mechanical model of an atom is described by three scientists: Louis de Broglie, Erwin Schrödinger, and Werner Karl Heisenberg. De Broglie describe or propose that the electron, which has been known as a particle, can also thought as a wave. So he described electrons as having a particle property and a wave property, while Schrödinger used mathematical equations to describe the probability of finding an electron in a certain position. Heisenberg, on the other hand, discovered that for a very small particle like electrons, its location cannot be exactly known and how it is moving. This is the time he came up with his principle called uncertainty principle, wherein he says that there is only a probability or a possible location where we can find electrons, and he called it as electron cloud, a region or space where electrons are likely to be found around the nucleus. Now, before we proceed, let's have the question bank. Which of the following best describes the quantum mechanical model of an atom? A. It describes an electron's probability distribution that determines the probable location of an electron. Letter B. It makes prediction based on Schrödinger's mathematical equation. C. It is the currently accepted atomic model. Or D. All of the above are correct. The answer is letter D. All of the above statements are correct about the quantum mechanical model. On the quantum mechanical model of an atom, they describe an atom as having an orbit called energy level. It is represented by letter N. It is numbered by 1, 2, 3, 4, and so forth, wherein the first energy level or the first orbit is the one that is the closest to the nucleus. Now, the energy levels can be broken down into smaller regions or smaller level called sublevels. Sublevels could be S or sharp, P or principal, D or diffuse, and F or fundamental sublevels. Every energy level is consists of one sublevel. So as you can see, on the energy level 1, we only have one kind of sublevel, which is the S sublevel. On the energy level 2, we have two sublevel, which is the S sublevel and the P sublevel. On the third energy level, we have three kind of sublevel, the S, the P, and the D. While on the fourth energy level, we have four sublevels, the S, the P, the D, and the F, and so on. Each energy level is broken down by sublevels. It could be S or sharp, P or principal, D or diffuse, F or fundamental sublevels. While these sublevels contains orbitals, when we say orbitals, these are the species that have a high probability of containing electrons. S sublevel have one orbital, wherein this is how S shape, or this is the shape of S orbital. The P orbital or P sublevel have three orbitals. It follows different axes. One follows the x-axis, the other one follows the y-axis, and the third one follows the x-axis. So we have three types of P sublevel. While the D orbitals or D sublevels have 5 types. And last, for the F sublevel, we have 7 types or 7 orbitals. To sum it all, different sublevels represent different elements on our periodic table. For the s orbital, it consists of group 1a and 2a, while for the p sublevel, it consists of 3a, 4a, 5a, 6a, and 7a on our periodic table, while the d sublevel is consists the transition metals, and last for the f sublevel. Here, numbers refers to the energy level. So let's have an example. Elements located on the second period of the periodic table have energy level 2. So the whole number before the letter represents the energy level. On the third period, we have whole number 3 that represents energy level 3. On the fourth period, we have 4s or 4 whole number that represents energy level 4. While the letters S, P, D, and F represents the sublevel. So we have here 2s to represents that the second period is consists of s orbital. On the other hand, we also have here on the second period the p orbital. Now the question is that how many sublevels are there on the third energy level? To determine or to answer this question, let's identify where is the third energy level. So on our periodic table, the third energy level is found on the third period, wherein it consists of sublevel S, sublevel D, and sublevel P. So how many sublevels are there in the third energy level? The answer is 3. We have the sublevel S, sublevel P, and sublevel D. Now, how many orbitals are there on the second energy level? Let's identify first where is the second energy level. So second energy level is found on the second period, wherein it consists of sublevel S and sublevel P. Now, sublevel S is consists of 1 orbital, sublevel P is consists of 3 orbitals. So to sum it all, we have 4 orbitals, 1 orbital for the S sublevel and 3 orbitals for the P sublevel, with a total of 4 orbitals found in the second energy level. Every orbital can carry a maximum of 2 electrons and a minimum of 1 electron. S orbital has a maximum of 2 electrons. It is because it consists of 1 orbital. So in every 1 orbital, there are or they can carry at least a maximum of 2 electrons. For p orbital that can carry or can have 3 orbitals, it can carry a maximum of 6. 2 electrons for each orbital. While for the d sublevel with an orbital of 5, they can carry a maximum of 10 electrons. For the f, we have 7 orbitals that can carry a maximum of 14 electrons. Now, what is the total number of electrons in an energy level? So for energy level 1, with 1 sublevel, it can carry 2 or maximum of 2 electrons. For the second orbital, it consists of 2 sublevel, the S and the P. S have 1 orbital, P have 3 orbitals. So for S orbital of the second energy level, they can carry a maximum of 2 electrons. For the P, they can carry maximum of 6. As a total, electrons found on the energy level, they can carry a maximum of 8 electrons. 2 electrons can carry by S orbital and 6 electrons can carry by P orbital, as a total of For the third orbital that consists of sublevel S, P, and D, wherein S have 1 orbital, P has 3 orbitals, and D has 5 orbitals, they can carry different amount of electrons, wherein S can have a maximum of 2, P can carry a maximum of 6, and D can carry a maximum of 10. As a total, the third orbital can carry 18 electrons. Same with the fourth or the energy level 4, which consists of sublevel S, P, D, and F. Each sublevel can carry different amount of electrons. As a total, the energy level 4 can carry a maximum of 32 electrons. Now, let's move on with the electron configuration. Electron configuration is a method of distributing electrons in different sublevels or orbitals, as well as in the main energy level. So on the electron configuration, this is how we can find or choose the probable location of electrons around the nucleus of an atom. A typical electron configuration consists of numbers, letters, and superscripts with the following format. A number that indicates the energy level, the sublevel, or the letter that indicates the sublevel. It could be S, it could be P, it could be D, or F. And a superscript that indicates how many electrons the sublevel can carry. Now, this electron configuration is summarized on this representation. Now, if we will straighten or i-straight natin yung lines to represent this electron configuration, we will come up with this one. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, and so on. Now, for you to easily remember or memorize this electron configuration, I have here a mnemonics. Si Sally pumasok sa pinto, si Daddy pumasok sa door, paano si Father Daddy, paano si Father Daddy, wherein C represents the 1s, Sally represents the 2s, pumasok represents the 2p, and so on. Now let's use this representation on a given element. Now let's say we have the sodium atom that have 11 electrons. Now for us to use this electron configuration, we must count the number of electrons or the superscript, wherein the total of the superscript or the electrons should be equal to the number of electrons of the specific element. So for sodium, we have 11 electrons. So to count the number of electrons on this electron configuration, let's count 11 electrons. So on 1s2 we have 2, on 2s2 we have 2, on 2p6 we have 6 electrons. So in total we have here 10. So 2 plus 2 plus 6 we have 10, and the total electrons of sodium is 11, so we need to have the next one, and we should have, or we should put 1 to have an equal electron, which is 11. So 1s2 we have 2 electrons, 2s2 we have 2 electrons, 2p6 we have 6 electrons. In a total we have now 10, but we need to have 11. So we need to include the 3s, but instead of putting 2, we need to put 1 for us to have 1 electron. So as a total, we have 11 electrons to represent the 11 electrons of a sodium atom. Now, let's try another one. This time, let's identify the electron configuration of iron, wherein it has 26 electrons. So let's count the number of superscript for us to have a total of 26. So 2 plus 2, 4 plus 6, 10. Plus 2, 12, plus 6, 18, plus 2, 20. Then on the 3D, that can have a maximum of 10, but we already now have 20. Only 6 is incomplete, so instead of putting number 10 as a superscript, we will put 6 to indicate that another 6 with a total of 26 electrons to represent the 26 electrons of an iron. Now, electron configuration can be written in a shorthand method, wherein short electron configuration are often written in standard notation, particularly for element with high atomic number. We need to say, for us to have a short representation of the electron configuration kapag masyado ng mahaba, or masyado ng malaki yung atomic number ng isang element. So to write the shorthand electron configuration of an atom, we should follow different steps. So let's say we have the rubidium that have 37 electrons. So masyado na siyang malaki. So for us to write it in a short form, instead of writing it this way, we should first identify the location of rubidium. So we have here the rubidium located on the 5th period or 5th energy level and on the S region. So we have 5s. So it is included or shown on the last part of its electron configuration. Now, for us to write a short method or shorthand method of this electron configuration, instead of writing it in a long term, we need to only write the noble gas. Noble gas is located on the last right part of our periodic table. So, for rubidium, ang sinundan niyang noble gas is the krypton. So, before rubidium, ang noble gas na meron sa periodic table is the krypton. So, instead of writing it whole, we should write the symbol for krypton enclosed on a bracket. So, dapat may bracket. So, instead of writing it, we will write a krypton symbol. Now, for us to identify the next one, we should know first the energy level. So, rubidium is located on 5 or 5th energy level and on the S region. So, we have 5s to indicate the location of the rubidium. So, rubidium is located on 5s. Now, which group rubidium is belongs? So, this is a group 1 possessing one electron. So, this column, all of them have 1 electrons or 1 valence electron. When we say valence electron, these are the electrons located on the outermost part of its atom. So to write the shorthand method for rubidium, we have open and close bracket, krypton, 5s, and 1 to indicate that an rubidium atom is have a valence electron 1. Another one, magnesium. So first, locate the location of magnesium. So magnesium is found on the second or on the group 2 of our periodic table, group 2A. So they have a valence electron of 2. Now, identify the noble gases bago si magnesium. So ang noble gas bago si magnesium is the neon. So, as you can see, pabalik siya. So, bago si magnesium, ang noble gas na meron is the neon. So we will write the symbol for neon inside an open and closed bracket. Now, to indicate the location, magnesium is located on the third energy level and on the S region. So we have 3s. Now, it is included on the 2a group. So the valence electron for magnesium is 2. So we have here. So the shorthand method for magnesium is neon 3s2. Now, filling of atomic orbitals follows different principles. The first one is the Alphabao Principle, the principle that is named after a German word Aufbauen, which means build up. The Aufbau principle dictates that electron will occupy an orbital with lower energies before occupying higher energy orbitals or energy level. So as you can see, it follows or it travels first on the lowest energy level, which is 1, then on 2, energy level 2, then on 3, and so on. Next one is the Pauli exclusion principle, wherein an orbital may occupy a maximum of 2 electrons. Each electron will have a different spin. The maximum number of electrons in each of the sublevel and orbitals is shown on the right. So, S sublevel is consists of 1 orbital. P sublevel have 3 orbitals. So it consists of 3 boxes, or it is being represented by 3 boxes. For D orbital, they have 5 D sublevel, it has 5 orbitals. That is represented by 5 boxes. For F sublevel, it consists of 7 orbitals that represents by 5 boxes. So on each boxes, they can carry a maximum of 2 electrons. And last, for the Hans rule, when an electrons occupy an orbital of equal energy, 1 electrons enter each orbital until all the orbital contain 1 electrons. Then the second electrons is added to each orbital. So it means that on the Hans rule, sinasabi na each orbital or each box should have first 1 electron. So bawat box dapat meron munang tigi-isang electron. So let's say for example on the P sublevel. So, bawat box ni P sublevel, dapat meron munang tigi-isang electron. So, 1 electron on the first box, another one on the second box, and another one on the third box. Then, this is the time we will add the second electron to attain the carrying capacity of each orbital. So, that is the time we will add another one for the first box, another one on the second box, and next on the third box. Same with the D sublevel. So we need to put first 1 orbital or 1 electrons, then we will add another one to sustain or to attain the carrying capacity or the maximum number of electrons that an orbital can carry. Now, let's try it. So let's say we have an element gallium with a symbol of Ga and atomic number of 31. Identify the expounded notation and shorthand notation of gallium. So I have here a letters or a choices. So let's start with the expounded notation. So what is the expounded notation of electron configuration of gallium? So gallium have 31 electrons. So we will count 2 plus 2 plus 6, 10. 2 plus 6, 8 plus 2, 10. So we have 20. Then another 10, we have 30. So we have 4p6. So we have 6 here. So a total of 36. But gallium only have 31. So letter A is incorrect. For letter B, we have 2 plus 2 plus 6. We have 10. 2 plus 6 plus 2, we have another 10. So a total of 20. Another 3d10. So we have 30. Then for 4p1 to have 31 electrons. So the correct answer is letter B. For the shorthand notation, we have here a choices. So first, identify the noble gas before gallium. So the noble gas before gallium is argon. So as you can see on the choices, the one with argon is letter C. So for P1, it is because gallium is included on fourth energy level or fourth period and on the P sublevel. So for P, and it is belong on the B1 part of our periodic table. So it has one valence electron. That's why we have one here. So that's it. You can now proceed to your task activity today. Thank you.